Hi everyone, I'm going to go ahead and take a look at the Try It Now number 3 problem from your textbook located on page 302. So if you'd like, please feel free to pause the video and grab the textbook so that you can follow along, and maybe grab some scratch paper as well. So to begin, I'm going to go ahead and read through the problem, and then I'm going to go through the explanation step by step. Some of this, because there is so much work involved, I'm going to kind of fast forward in my explanation. So please, if you need to, feel free to pause the video or take note and try to fill in some of those gaps. And if you need to, of course, please come and see me or send me a message. Okay, to begin, the problem reads, a small radio transmitter broadcasts in a 50-mile radius. If you drive along a straight line from a city 60 miles north of the transmitter to a second city 70 miles east of the transmitter, during how much of the drive will you pick up a signal from the transmitter? So what we're trying to do here is, I've actually gone ahead and labeled it out and sketched it. The red that you're seeing here is how far the transmitter is transmitting. So we know that it has a 50-mile radius. What I've opted to do is I've done a coordinate plane with it using a scale of 10. And our transmitter, that I'm going to go ahead and note in green here, is located at the origin of this coordinate plane. I know that my city, which I've labeled at start, is going to be 60 miles north, so that's why it's at the 6th tick mark on the y-axis. And we're going to finish at the second city, which is going to be 70 miles east, so that's why I have it on the 7th tick mark on the x-axis. So to begin, let's go ahead and try to boil this down or bring this back to some information that we know. First off, with regards to the circle, we've discussed this in class, and 5.1 kind of goes into a great amount of detail, mentioning how we can create an equation for a circle. If you recall, the equation for the circle would be x minus h squared plus y minus k squared is equal to r squared, and where r squared is going to be representing your radius. Now in this case, since our transmitter is at the origin, so the center of the circle is also at the origin, we know that h will be 0 and we know that k will be 0. If you recall, h and k are basically just special markers for the x value and the y value of the center point of the circle. We know that our radius here is going to be 50. If we go ahead and substitute those values and clean up, then we end up getting an equation that reads as x squared plus y squared is equal to 2500. So we want to keep this in our back pocket. We are going to work with this. The other thing that we want to note here is that we do have a straight line. In other words, the road that we're going to be driving on. And since we have a straight line, let's pull our information all the way back from pre-calc 1, where, and actually probably further than that. But we know that we can create an equation of a line, and it has a general format that looks like y is equal to mx plus b, where m denotes our slope of the line and b represents the y-intercept. And in this case, we do have some information that we can work with. We do have a y-intercept at 0, 60. In other words, that's the coordinate point of where we start our journey. And then we also have another coordinate point at 70, 0, which is going to be the point at where our trip ends. So we can use this information to help calculate the slope. So our m is going to end up being 60 minus 0 all over 0 minus 70. And we can clean this up, and then it will end up becoming negative 6 over 7. We also already have our y-intercept, so we can go ahead and create our equation of the line. Y is equal to negative 6 over 7 times x plus 60. Okay, believe it or not, these two pieces are going to help us greatly in determining the distance that we need to find here. because again, to kind of highlight, we want to know the distance, and I'm going to highlight this in orange. We want to know basically what I have in orange here. What's this distance? In other words, this is the distance that I'm going to be able to hear the radio for. Okay, once I'm outside of that circle, I no longer get that radio transmission, and I can't hear that music or NPR or anything like that. So let's go ahead and return. Okay, so one of the things that we want to know here is, again, we're kind of talking about, we want to find coordinate points, and I'm going to go ahead and I'll denote those in pink. So basically the start of when I can pick up the radio and the end of when I can pick up the radio. So I want to find those two coordinate points, because if I can find those two coordinate points, then I can use my distance formula and then find out how much of that road trip, or how long that distance of the road trip that I'm going to be able to pick up that radio signal. So this is kind of pulling back from Math 141, where we were looking at for intersection points of two lines. In those instances, we were able to basically set them equal to each other because they're sharing the same value. We can kind of do the same thing here. So notice here, my equation of the line says y is equal to -6/7 x plus 60. So what I'm really saying is, if I know that y is equal to this, then I can go ahead and substitute it in there. So this is going to look like x squared plus, and instead of y, I'm going to put in that whole -6/7 x plus 60. That will be squared, and that is going to be equal to the 2500. Okay. So let's move this up so we have a little bit more space to work with. All right. One other thing that you're probably going to want to do is, probably on a separate sheet of paper, you might want to do an aside. And basically why we want to do that is because this -6/7 x plus 60 that we're going to square, that's not going to be like nice and clean and pretty. So we might want to do some of the dirty work on the side and then bring it back into our work. So this way our eye isn't so overwhelmed with all these steps that we're doing. So I'm going to go ahead and kind of fast forward, but one thing that I do want you to remember is that, remember, -6/7 x plus 60 squared is the same thing as -6/7 x plus 60 times -6/7 x plus 60. So in other words, we're going to need to FOIL. If you were to FOIL this, this ends up coming out to be 36/49 x squared minus 720/7 x plus 3600. Okay, so I did a huge jump here, again, just to save a little bit of time. But what I want you to note here is probably pause the video and make sure that my work matches up with yours before continuing. Okay, so now that that's all done, I'm going to go ahead and basically rewrite this expression here. So this ends up being x squared plus, and I'm just going to substitute this back in now. This is 36/49 times x squared minus 720/7 times x plus 3600 is equal to 2500. So again, I just did a substitution here. So now I'm going to clean some of this up. So I do see that I have two like terms right next to each other right here. And if I do a little manipulation, I can combine these two like terms. So in other words, in order to do that, I'm going to go ahead and subtract 2500 from both sides. And I'll again explain why I'm subtracting the 2500 from both sides instead of subtracting the 3600 from both sides. What I want to note here is that I do have a coefficient of 1 in front of here. And since my other one, or my other term, has a coefficient of 36/49, I'm going to go all the way back to my knowledge of fractions, and I'm basically going to make it so that this 1 has a denominator of 49. So in other words, I'm going to write this as instead of a 1, I'm going to write it as a 49 over 49. So now I can combo or add these two coefficients together. All right, so this comes out to 85 over 49 times x squared minus 720 over 7 times x plus 1100 is equal to 0. At this point, we're probably looking at this going, oh God, there are a lot of fractions in here. I don't like what I'm seeing. This makes me uncomfortable. The good news is you do have access to calculators to help you out here. So what I'm going to go ahead and do is I'm going to go ahead and work with these. And the nice thing about this is I have a quadratic here. So I can use my quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so again, note as well that the 2a is dividing the negative b and that plus or minus square root, b squared minus 4ac. It's not just dividing one of those items. So I do know that my a is here, my b is here, and my c is here. Always make sure that your quadratic is written in descending order before you identify what is a, what is b, and what is c. So I'm going to scoot this up again. All right. So if we go ahead and drop these items in, this gives me the following. I will have x is equal to a negative, and note that I do have a negative 720 that's going to go in for b, plus or minus the square root of negative 720 all over 7 squared. But since I'm squaring it, that negative would go away. Minus 4 times a, which is 85 over 49, times c, which is 1100. And this whole thing is going to be divided by 2 times 85 divided by 49. Okay. Bear in mind that this is one way that you can set this up. There is an alternative way that you can clear out all the fractions and then work with those numbers. If that's something that you're interested in, please come see me or ask a fellow classmate. Perhaps they know. Okay. So we have a lot of work here. So I'm going to kind of show you basically some steps here if I were cleaning this up. Okay, so bear with me. So first off, the negative 720 just becomes just a positive 720 all over 7, plus or minus the square root of, here's where I'm going to break out my calculator and I'm going to start working with decimal values instead. So if I square that negative 720 all over 7, that's going to give me 10,579.59184. And I'm going to basically extend out that decimal as far as I can to maintain accuracy in the answer. If I go out, or if I round too soon, I'm losing accuracy and my numbers might be a little bit off. And then if I take care of that multiplication after the subtraction sign, I get 7,632.653061, and that's going to be all underneath that square root. And then if I also do 2 times 85 over 49, that's going to give me 3.469387755. Okay, so if I were to continue to do this, I end up getting 720 over 7 plus or minus the square root. And let's go ahead and continue to add that up. So if I take care of that subtraction, I now have 2,946.938779, and then again all over 3.469387755. Continuing on, still haven't addressed this 720 all divided by 7. But if I take the square root of the 2,946.938779, this comes out to 54.28571432 all over 3.46938775. Okay, so now I'm going to go ahead and basically default to my calculator. Again, since this is using the quadratic formula, I'm going to get two solutions. My two solutions will end up coming out to be 45.2941766, and then I will also get 13.9 repeating. Okay, so at this point, again, I haven't rounded anything because I wanted to show an accurate answer for you, especially if you're following along in your calculator. If I start rounding and truncating too soon, my numbers are going to be slightly off from yours, and I didn't want to necessarily throw that confusion at you, especially since I'm not right there to help answer that question. So I know that x is going to be equal to these two solutions. So what I want to do now is, if I know the x values, I can find the y values. So in other words, bear with me, I'm going to go straight up really quick, back to my picture. So the start that I have here, my x value is probably at about 13.9 here, repeating. And my finish, or sorry, not my start and my finish, but the start and the finish of where I start getting those the radio transmission, this is probably around where the 45.29 is. Okay, but now what I have to do is I need to find out what these y values are in order to complete those two coordinate points. So let's dive back. This is not a light problem. So the good news is, recall that we do have our equation of the line. Y is equal to -6/7 times x plus 60. If I know the x's, if I know the x values here, I can simply substitute them in one at a time and find out what my y values are. So at this stage in the game, if we were to go ahead and put those in, let's go ahead and do that. So if we do y is equal to -6/7 times 45.2941176 plus 60, I will get an output of 21.1764758. And then if I also plugged in 13.9 repeating for x, and evaluated that, my y value would come out to 48.1234567 zeros and then a 1. So now I have my two coordinate points. So I have one coordinate point, and here I'm going to start rounding it off because at this point we're going to be okay. So here's my 45.29 and my 21.18 if I round these off to the second decimal place, and here I have 14 and then 48. Okay, so again, let me scroll all the way back up. I can go ahead and drop these two values in here. I had 21.18. Okay, so if I have these two coordinate points, then I can go ahead now and find this distance. So let's go all the way back down. Sorry for all the scrolling. I'm almost done, I promise. So recall that your distance formula is the square root of your first x value minus your second x value squared plus the difference of your first y value minus your second y value squared. So in our case, we have 45.29 minus 14 squared plus 21.18 minus 48 squared. If we continue to clean this up, then we will get 31.29 squared plus -26.18 26.82 squared. Recall here that we never want to have a negative as our final answer. So in the middle of your work here, notice that we do have a negative, but you shouldn't worry about that because notice that the negative value is going to be squared. In other words, it's going to be cleared out, because if you square a negative, it becomes positive. So as we continue to do this work, we'll get 979.0641 if we square 31.27. And then if we square that negative 26.82, we get 719.3124. Continuing to clean that up, if we do the addition, we get 1,698.3765. And then if we take the square root, this is going to come to about 41.21 miles. So this is how much of the trip we're going to be able to gain access to listen to that radio transmission. So again, bear with me as I scroll up once more to our picture. Look at all this work that we did for one problem. So this distance here, so from this pink point to this pink point, this is a total of about 41.21 miles. Okay, so to close off this video, remember that we did do a lot of work. I did go a little bit fast, so please make sure that you are filling in all the work and double checking to make sure that everything makes sense. But also bear in mind that the majority of the tools that we utilized, it's really nothing new. We pulled a lot of our prior information, especially from algebra and pre-calc, in order to help us solve this. So we're basically just learning to use our tools in different ways and using new perspectives to approach these different problems. So I hope this explanation was satisfactory. If you do have any suggestions on how to improve the video, or to improve the explanation, or you would like some more one-on-one time with me, please take the time to send me a message or stop me before or after class. I hope this was helpful. Have a good day.